Before we can really get into these theories, we have to talk about the types of chemical bonds and why bonds form. Chemical bonds form because they lower the potential energy between the particles that compose atoms. And it's the charged particles that we're most concerned about, the protons and the electrons. Many things in nature happen because of lowering the potential energy. It's like, balls rolling down a hill. They roll down a hill and they're going to end up at the bottom because it's lower potential energy. So as we get two atoms approaching each other, there are several different interactions that happen. We have electrons repelling each other, and we have nuclei repelling each other because like charges repel. And then we have electrons and nuclei being attracted to each other. And so there's an interplay between these three different interactions. A bond will form if these interactions result in a net reduction in energy. If the energy isn't reduced, a bond doesn't form. I've talked a lot about energy in terms of relating it to money. And it's like, okay, if this complex deal works out so that there's a monetary payback, we're going to go forward with it. If this is going to end up costing me money, the deal's off. But sometimes these things are kind of complicated. But the bottom line is you lowering the potential energy. So ionic bonds, this is one type of bond. Metals have low ionization energies. We've looked at periodic trends, and we see that the metals have lower ionization energies than the nonmetals do. So they will tend to lose electrons to form cations. Nonmetals have negative electron affinities. That means that they like to gain electrons, and so they form anions. And so this is the ionization energies, the electron affinities, and our understanding of the structure of the electrons helps us to understand why these things happen. But back in, I think it was chapter 5, we learned in nomenclature about what these do. And so this is more of the explanation. So what happens is the metal transfers electrons to the nonmetal. And the result is we have oppositely charged ions, and then they're attracted to each other. So when we have metal and nonmetal elements, we're going to have an ionic bond, and ionic bonds are characterized by electrons being transferred. Let's do some highlighting here. That's not, okay. Transferred. Ionic bonds, electrons transferred. You've got a metal and a nonmetal. When you've got two nonmetals, you get a covalent bond. Covalent means sharing valence electrons. Electrons are shared. Those are the two most important types of bonds. And there's another type of bond between different metals. Excuse me, too much Dr. Pepper. Two metals. Then you get a metallic bond. And in a metallic bond, the electrons are pooled. They're not shared, they're not transferred, there's just this sea of electrons that holds the metals together, and we'll talk about those. In a covalent bond, this happens between two nonmetals. We don't here have a metal who's willing to give up an electron. The nonmetals want to become anions. They have negative electron affinities. They would be happy if they got an extra electron. But if you look at, say, hydrogen and hydrogen, and the one hydrogen saying, hey, give me your electrons so I can have a full valence shell, and the other electron says, no way, because then I won't have any electrons at all, and that would be horrible. And so they can't decide who's going to give up an electron, so they decide that they'll share their electrons. And those shared electrons will interact with both nuclei. So the electrons between the atoms are shared, and there's an attraction between those shared electrons with the nucleus from each atom. The most stable situation is when the shared electrons are between. And so here we have the most stable arrangement. Here the red circles are the nuclei, which have positive charges, and here's a shared pair of electrons, which has a negative charge. And when this is between, we have the maximum attraction. When these are over here, there's not as much attraction. And when they're over here, it's even less. And so this is the lowest potential energy situation. and that is a bond between those two nuclei. Metallic bonding happens between metal atoms only. Metals lose electrons easily. The simplest model here is called the electron C model. And so we think of this in this way. All the atoms in the metal lattice pool their valence electrons, and those electrons are delocalized. They're just kind of spread out over the entire metal. And then the positive nuclei are attracted to this negative sea of electrons. I sometimes talk about electrons as being like children or like little boys. So in this situation, the moms would be the families are the atoms, and they send the kids out in the neighborhood to play. And the moms don't go out there and watch the children. This is like when I was a kid. You were just sent out to play, and you roamed the neighborhood, and when you got hungry, you came home. Or when it got too dark to see your hand in front of your face, you would find your way home. And so there's this sea of electrons. There's these electrons just out there, and they're not specifically associated with any one atom. They're just free to move around. But there's an attraction between this negative sea and these little islands of nuclei. And so the metal holds together.